Okay, so for 16, they want us to write the standard form. And so remember that the standard form is the standard form is given as x minus h squared plus k, and there's a number in front. Okay. So what we want to do is take our function and rewrite it so it looks like this. Okay. So the first thing you want to do is kind of separate the constant on its own. So I'm going to write it out here on its own. And then whatever is in front of x squared has to be a positive one. So we need to get rid of this negative. So I can get rid of it by factoring it out. So if I take it out, I'm left with x squared, and this negative here, it comes out, I'm left with a positive 4x. Okay, so you always want to make sure that x squared is positive. Once you have it in this format, then the next step is to look at the b and take half of it. So half of 4 is 2. And then you're going to square it. So then we're going to square it so we get 4. Okay. So this number 4, we're going to add it in here, but we're also going to subtract it. Because what we're really doing is adding a 0, right? 4 minus 4 is 0. So then what we want to do next is we're going to leave the 4 here, but this negative 4 we want to bring out of the parentheses. So in order for me to bring it out, I have to multiply it by whatever number I have here. So a negative times a negative 4 is going to be a positive 4. So I'm going to have that over here. So I have the 1, and then I'm going to add a 4. Okay. So let me repeat that. So this negative 4, we multiply it times a negative 1. So it comes out as a positive 4. By doing this, the parentheses down here can be factored. And so that's going to be x plus 2 times x plus 2. 1 plus 4 is 5. Okay. And so remember, the little trick here is whatever you get half of this number is what you're using here. Okay. And since they're the same, x plus 2 and x plus 2, I can write it as x plus 2 squared plus 5. So then from there, in your exam, it's going to ask you to identify the vertex. So the vertex is h and k. So in this case, since we have a positive 2 here, it comes out as a negative 2, and then we have our 5. So that's going to be your vertex. Your axis of symmetry is just the x coordinate of the vertex. So we have x equals negative 2. And then it's also going to ask you for the x-intercepts. So the x-intercepts, you can use the equation the way it's written here and use a quadratic formula if you want to. Okay? Or you can use the standard form. So that's going to be up to you. Like, you can use this with the quadratic formula, or you can use this with the standard form. So I'll just use this one here. So we let y equals 0. I'm going to subtract 5. I'm going to divide by negative 1. Take the square root. So since we're taking the square root here, it's plus or minus the square root of 5. I'm going to continue up here. X plus 2. Subtract the 2. So that would be our answer. So on the test, it wants you to enter it as an ordered pair. So you would enter the smallest number first, and then y is 0, and then you would enter the other one. So this is how you would enter your answer. Okay. Any questions on that one? And then you need to identify the graph. So you will look for the graph that is opening down, right? Because it has a negative. It's moving to the left, and it went up 5. Okay. All right, so let's look at number 15. Any questions on 16? Okay, 15. Sketch the graph. Okay. So in order to sketch the graph, you need to do a couple of things, right? Number one, the end behavior will be helpful. Number two, the X-Intercepts / zeros. Number three, the Y-Intercept. And number four, you want to plot additional points. Okay. So the end behavior, you have x to the 4th. So remember the choices for the end behavior are, this is x squared, this is negative x squared, x cubed, so since our exponent is even for the degree, then they're going to be in this option or this option. And then the number in front of x squared is positive, so that means that we're going to be in this situation. So your end behavior is going to look like this, which we just say that it rises right and rises left. Okay. So on your homework, on your review and your exam, you have to identify the graph. They give you different graphs, right? So if you see a graph that is opening down, you know that's not the answer anymore. Okay. Just by doing this first step. Okay. The Y-intercept, this is where you let x equal 0 and solve for y. So if you put 0 here, 0 here, and 0 here, then we get y. A 0, right? So this is 0 minus 0 minus 0 is 0. So your Y-intercept is 0, 0. For the number 2 X-intercepts or zeros, you have options. You can try to factor, or you can use synthetic division with the possible zeros. Since they all have at least an x in common, then I would try to factor first, because it might be easier. Okay. So either way, we let y equal 0. So they all have at least an x squared, so I'm gonna factor out an x squared. So from the x to the 4th, if I factor out an x squared, I get x squared. From x cubed, if I factor out x squared, then I get an x. And if I factor the x squared here, I get a 20. Okay, so I can set this equal to 0. So for this one, I get x equals 0 if I solve for, take the square root on both sides. But since it's x squared, that means that x equals 0 is actually repeating twice. Okay, which is important because that tells you that If it's repeating 2 times, then the graph is going to touch and turn when you graph it. Okay. Here we can either use the quadratic formula or you can try to factor. I'm going to factor since it's factorable. So my 0 is x equals 5 and x equals -4. Since these only appear one time, then I know that the graph is going to cross at those 2 points. Okay. Any questions on that one? Okay, so now we can plot the information that we have. So we have 0, 0. We have x equals 5. And x equals -4. Then we want to use the end behavior. I always like to use a pencil to do the end behavior first, and then I come back and use the pen in case I need to erase. But at this 0, at x equals 5, we know that the graph is going to cross, and we know that it's rising right and rising left. So here, this is going to go up and through the point. Okay. At this point, we know that it's also going to cross, and we know it's rising to the left. So it might look something like that. At x equals 0, the graph is touching, so we don't know if it's this way or if it's this way. It might be either or, right? So in order to decide, we need to pick additional points so we can know what's going on. So the points you choose, I would encourage you to choose them in here so that you can better graph it, okay? Because we need to know this point, is it going to be up here? Is it going to be down here? What's going to happen? Okay. So we can plot f of 1. Let's do f of 1, and maybe we can do, I guess we can do f of -1 and 2. You can pick as many points as you want or as little as you need. So it's up to each of you to decide how many you need. So we plug in the 1 in here. We're going to get 1 minus 1, and then this is going to be a -20. So what do we get?
It's just -21.
The answer? Yeah, yeah, because this is 0 here, right?
Yeah.
And that's going to be a -20. So f of 1 gives me a -20. So I'm going to put it somewhere down here, like the point. Okay. And f of -1, well, -1 to the 4th power is a +1. -1 cubed is a negative, and a negative would be positive. So that's 2. And then -1 squared is positive, and then 20, so that would be a -18. So -1 is -18, so somewhere a little bit higher. Maybe like right there. Now, will our graph cross this y-axis here? What do you think? Can I connect these points? I can't, right? Because that means that this would be a y-intercept, but our y-intercept was 0, 0. Okay. So then 2 would be 2 to the 4th minus 2 cubed minus 20 times 2 squared equals, so 2 times 2 is 4, times 2 is 8, times 2 is 16, minus 8 is 8, right? 2 times 2 is 4, and then that's 20, so that's 80. So 8 minus 80. So that would be a negative 72. So f of 2 is going to be even further down, right? So I'm going to put it here. And negative 2 would be, that's still 16 plus 8 minus 80. So 80 minus 8 minus 80 is 72, negative 72. And then we have 16. So that's 56. So a little bit higher, like right here, maybe. So negative 2 is going to be 56. And I already forgot what these numbers is. So this is 72, so maybe like around here. So the graph is going to come down to these points. But then it's going to come back to a 0. It's going to touch the 0. Right? It's going to touch the 0. And then it's going to come back down to the points. And then it's going to go back up. So our graph is a little distorted, I guess, because we have big numbers down here that we're kind of squeezing them together. Okay. But just so you have an idea, these are the choices that you would have had if you were taking the tests. Okay. So if we check them, 1, 2, 3, 4, 5, so that's your 0 here. That's your 0, that's okay. The zeros are okay there. This one has a 0 here. This is a negative 4, a positive 4, and a negative 5, so that's not the right one, right? And then this is going to be a negative 5, which shouldn't be a negative 5, and a positive 4, so that's not going to be your choice either. And then over here we have negative 4, positive 5, and the 0. So it's between this one and this one, okay? So then, you know that at 0, it's supposed to touch and then turn. Well, at this 0, it goes through it. So now I can say this is my answer. Okay. But if you graph it on your paper, then you can compare. But this might be kind of hard to compare. Well, I guess you know it's touching here, so that's the big difference here. Okay. So those are little ways. So you could have graphed this just by doing 1 and finding the actual zeros. All right, so let's go to 14. So same idea, sketch the graph. So we need to find these steps here. Okay, so end behavior. So now you have a degree of 3 with a positive number in the front. So we're going to be in this situation, right? Degree is odd with a positive coefficient. Odd, positive coefficient. So we say that the graph is going to rise, right, and fall left. The y-intercept, if we let x equal 0, then we just get 0. So my y-intercept is 0, 0. Okay. That's not always going to be the case, but in this situation it is. And then of course we're going to do additional points. So let's find the zeros. The x-intercepts, which are the zeros. So if we set that equal to 0, again, you can use synthetic division or you can factor. If you're able to, if they have something in common, I would factor first. to see if I can simplify it. So they each have at least an x. I can factor out an x. So it gives me x times x squared minus 25. Set each one equal to 0. At the 25, so take the square root, x equals plus or minus 5. So your zeros are 0, 0, 5, 0, negative 5, 0. And since all your zeros are only appearing one time, they're all going to be crossing, right? Crosses. Here's your 3 zeros. And then if we apply the behavior, it rises to the right and it's going to cross. So this would be something like this. And then on the last zero, it's going to fall left and it's going to cross. So it's going to be something like this. And then this point will either cross here or it's going to cross this way. Okay, so then we need to plot extra points. So you can get some from this side and some from here. So I'll put them up here. So if we plug in a 1, we get 1 cubed minus 25 times 1 equals negative 24. And again, it's going to be big numbers, so maybe we can do by 5s. So I'm going to do by 5s. So that's 5, 10, 15, 20. We get 24, so maybe like somewhere here. And f of negative 1 would be a negative 1 plus a 25, so that's positive 24. 5, 10, 15, 20. So maybe around here. And then I'm going to do f of 3. You could do f of 2 if you like. I'm going to do 3. So 3 times 3 is 9. And 9 minus 25 times 3. That's 9 minus 75, right? Or is that 66? Negative 66. So f of 3 is going to be down here somewhere. F of negative 3 would be a negative 9 plus 75. So we're on the opposite side. So somewhere up here. Okay, so that kind of gives me enough information for me to draw my graph. So this is going to go down like this. And then it's going to go up. So if I look at these two graphs, this is opening in the wrong direction, so I know that's not going to be an answer, okay, just by the behavior. Then the other choices are, this is going down, right? So that's not a choice. And this is going up, that's not a choice. So for 10, it says write the answer, perform the operation and write in standard form. So the standard form is a plus bi for complex numbers. So here they have 5 minus 3i squared. So what we can do is rewrite it. We can rewrite it as 5 minus 3i times 5 minus 3i. So we're going to multiply 5 times 5, 25, 5 times negative 3i, negative 15i, minus 15i. Negative 3i times negative 3i is positive 9i squared. Negative 15i minus 15i is negative 30i. And then this I squared, we can write it as a negative 1. So that gives us minus 9. 25 minus 9. 16. Find the rational zeros of the function. Okay. So here it's a little bit different because in these problems that we did earlier, we were also finding the zeros, but it was easier because we could factor out a number, right? Here we cannot factor out anything. So the first thing you want to do is figure out what are the possible zeros. Okay? Not the actual zeros, but the possible ones. And to do that, we're going to write P over Q, which P stands for the factors of your constant. Okay, so 30 is my constant. So I'm going to write down the factors of that, which are plus or minus 1, plus or minus 30, because 1 times 30 is 30, plus or minus 2, plus or minus 15. 2 times 15 is 30. Plus or minus 3 and plus or minus 10. And then you have 5 and 6. So I kind of squeezed it in there. But you have 1, 2, 3, 5, 6, 10, 15, and 30. And then the Q is the factors of the coefficient of your degree. So this is a 1. So just plus or minus 1. So if you divide this, 1 divided by 1 is 1, 2 divided by 1 is 2, and so on. So these are your possible zeros. So you might have a question where it asks for the possible zeros. So that's what they're talking about, right? So once you have your list, what it does is instead of checking an infinite amount of numbers, it kind of gives you a list to use synthetic division and see which one works. So I always start with 1. So I'm going to use synthetic division. So x cubed is going to be a 1. There's no x squared, so I use a 0. And then you have x, and you have your constant. Bring down the 1, so 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 1. Negative 31 plus 1 is negative 30. Times 1 is negative 30. Plus 30 is a 0. Since you got 0, that's a good thing, because that tells you that x equals 1 is a 0. Okay. But now we can use these numbers down here to get your quotient. So your quotient is going to be 1 power less. So if we have a 3, we're going to start with x squared. For the 1 is x squared. And then this one would be an x. And then this is your constant. Okay? So this is your quotient. So if you notice, your quotient is now quadratic. So that means that we can set it equal to 0. And you can either factor or use a quadratic formula. This one does factor. So 5 and 6 would give me a 30. And I need this to be a positive. So x minus 5 equals 0, x plus 6 equals 0. So these would be your zeros. So your answer that you would enter into your computer would be they already give you the x in the computer, so you would just enter -6, 1, and 5. So for 5, they tell you these are the zeros, and they want us to find a polynomial, so your answer might look something like this. Okay. Well, since you have a complex 0, then the conjugate is also going to be a 0. Okay, so automatically you want to include the conjugate as a 0. Okay. So my zeros here are x equals 1, x equals 4i, and x equals -4i. Then you need the factors. So the factors is just moving the 1 to the left side. So we get x minus 1, x minus 4i, and x plus 4i. So we're going to have some polynomial. You can call it f, g, h, whatever you want to call it. It's going to have a leading coefficient. And then I'm going to write down my factors here. So we multiply it out. X times x. Oops. X times x is x squared. X times 4i is 4ix. -4i times x is -4ix. -4i times positive 4i is -16i squared. We're going to gather our terms. 4ix and -4ix is 0. And then this I squared here is a -1, right? So -16 and -1 is a positive 16. Then we're going to multiply the next factor. X times x squared is x cubed. X times 16 is 16x. -1 times x squared is -x squared. -1 times 16 is -16. I like to have them in order and combine our like terms, of course. So we get x cubed minus x squared plus 16x minus 16. Since they don't give you other information, then the an, you can just make it a 1. Okay, so you would enter your answer as x cubed minus x squared plus 16x minus 16. If they give you other information, like, for example, they gave you, it might be something like this, like f of 2 is equal to 18 or something, then you would plug in the 2 for all your x's here, and the 18 would be on this side, and you were solving for an. Okay. And there are some of those on their homework for that section. Okay, but they don't give you this, so your answer is just going to be this. Okay. Okay, so use the given 0 to find all the zeros. Okay, so what we can do is use synthetic division using the 0. Okay, so I'm going to have 3 plus 2i. And then I'm going to have 1 for x cubed, -8 for x squared, 25 for x, and 26. So we bring down the 1, and then 3 plus 2i times 1 is 3 plus 2i. So we need to add this. So -8 plus 3 is -5 plus 2i. Okay, then your next step is to multiply this, right? So if we multiply that, I'm going to work it out on the side over here. So we have 3 times negative 5 is negative 15. 3 times 2i is 6i. And then negative 10i. And positive 4i squared. 6i and 10i is negative 4i. This is going to be a minus 4. So we get negative 19 minus 4i. Any questions so far? Okay, so if we add 25 plus 19, it is going to be what? 6? And then we need to multiply again, right? So I mean, you could just multiply from here, but I'm going to write it on the side. 3 times 6, 18. 3 times negative 4i is negative 12i. 2i times 6 is positive 12i. And then minus 8i squared. The 12i's become 0. This is going to be 18 plus 8, which is 26. And then minus 26, so we get 0. So we have to get a 0 here, right? If we don't get a 0, that means you multiplied or did something wrong. Why do I have to get a 0? Because they tell me that it's a 0. Okay. So then the next step is we're trying to find the zeros. So this right here is a polynomial, right? So the quotient is going to be x squared. And then I'm going to write this here. X, right? So this is going to be, and then this is going to be your constant. Okay. So we are going to run synthetic division again, okay? But instead of this 0, what is another 0 that I know for sure? I know the conjugate is a 0, right? So 3 minus 2i is also a 0. So again, if you have imaginary number, then your conjugate is automatically a 0, okay? Just like we did here, 4i and negative 4i. So my synthetic division that I'm going to use now is, I'm going to have 3 minus 2i, and I'm going to use a 1 for my x squared, negative 5 plus 2i, and 6 minus 4i. So we're going to bring down the 1. 1 times 3 minus 2i is 3 minus 2i. Negative 5 plus 3 is a negative 2, and the i's cancel. And then negative 3 minus 2i times negative 2 is negative 6 plus 4i. So I get a 0, so that's a good thing. Okay. Since you started with x squared, then this quotient is going to be an x, right? So my quotient here is just going to be x minus 2 is your quotient. Well, if you solve for x, then you get x is equal to 2. So your third 0 is x is equal to 2. You should have 3 zeros, so we have 1, 2, 3. And I know it's 3 because the degree is 3. Okay. Question on that one.